Evening, everyone. So I got lot of requests on my previous video regarding the new topics that have been added in Git. So I thought of coming up with a quick video, which is quite frankly oriented from an exam point of view to discuss about Bailar twist and Ray-Dutt twist, right? What are the main key aspects and where is this twist useful, right? So when you talk about your tris chelate complexes, right? Metal tris chelate complexes, like for example, nickel diethylamine thrice. So these complexes, these bidentate ligands, tris bidentate ligands attached to a metal, they are optically active. Even if the same bidentate ligand is attached to it, you can see the structure over here. It acts like a propeller. Okay, so they have kind of, you can say they possess helical chirality. So this over here is basically, let's say this is one isomer, okay, or this is one particular you can say enantiomer, and this is the other enantiomer, right? So these are optically active basically. And now what has been proposed is, what are these Bailar twist and Ray-Dutt twist? These are mechanisms which have been proposed by which these octahedral complexes, okay, by which octahedral complexes undergo racemization. Okay, octahedral complexes undergo racemization. Okay, undergo racemization. So now what is so special about these twists? So the key feature over here is that in these twisting mechanisms, the earlier racemization or isomerization mechanisms that had been proposed before this were basically substitution based mechanisms, or where the bond breaking was taking place. Okay, now twisting mechanism is a very important mechanism because over here there's no bond breaking. Okay, isomerization basically without bond breaking. So this is basically a twisting mechanism. Without breakage of bond, how can a octahedral complex isomerize? So for basically that kind of isomerization, two mechanisms were proposed. One was your Bailar twist and the other was your Ray-Dutt twist. Okay, so what happens in Bailar twist and what are the key differences between both the twisting mechanisms? So both of these mechanisms predict the same thing, that how a octahedral complex, in particular metal tris chelate bidentate ligands, how they basically undergo your isomerization or racemization, right? So they predict the same thing. It's just that the mechanism that they have proposed is different. And anyway, so coming back to this key differences between both of them. So I'll talk about how the racemization takes place, and I'll just show it to you over here. I've taken the structure just to explain how the twist takes place, but let's just see the key differences between both of them. So Bailar twist is also sometimes referred to as a trigonal twist. Okay, in this case, what has happened, what the mechanism proposes is that one of the chelate rings is moved while the opposite faces remain the same. Okay, so out of the three rings that are there, one ring is moved and the other two are remain in its position. And it undergoes through a D3H intermediate. Okay, so this is a very, very important point from an exam point of view, that this particular Bailar twist goes through a D3H intermediate. Whereas if I talk about a Ray-Dutt twist, then Ray-Dutt twist is also called as rhombic twist. So Bailar twist is called trigonal twist. This is called rhombic twist. And in this case, one ring is fixed and the other two are rotated. Okay. So in this case, you can see that two opposite faces were fixed and only one ring was moved. In this case, one ring is kept fixed and the other two rotated. I'll show you how in the next slide. Okay. And the most important feature of this particular reaction is, this particular mechanism, the Ray-Dutt twist, is that it undergoes a C2V. It undergoes through a C2V transition state. Okay. So that is the key difference between both of them. This undergoes through a higher, you can say higher symmetry transition state, and this undergoes through a lower symmetry transition state. Now let's look at the difference between both of them. So this A mechanism that I have written down over here, in fact I have not written down, I have taken this excerpt from Shiver and Atkins. It had been presented really well over there. So this particular mechanism is basically called your Bailar twist. Okay, that A1. Okay, this is your Bailar twist and this is your Ray-Dutt twist, right? Ray-Dutt twist. So what is the mechanism? You can see over here that once the rotation takes place, you can see this, in both the cases we obtain a trigonal prismatic intermediate. Okay, that is also one feature that is important. In both the cases we undergo through a trigonal prismatic intermediate, but their symmetries are different. Now if you see over here, if I basically pass an axis through this point, okay, let me just use some other color pen. Yeah, so if I pass an axis over here and rotate it by basically I rotate it by a C3 axis. Okay, that's I rotate by 120 degree, I will get the same same kind of transition state, right? If these all three rings are same, like for example, when I take the case of ethylene diamine, nickel ethylene diamine, right? So in that case, what I'm obtaining, I'm basically obtaining the same molecule, And then if I pass an axis through this end and then rotate by C2, then also I'll get the same molecule. So basically this intermediate you can see over here has a D3H symmetry. Okay, this intermediate over here has a D3H symmetry. But when I come to the Ray-Dutt twist, the intermediate is trigonal prismatic only. But now if you see, it does not have a C3 symmetry. Now it only has a C2 symmetry where I can pass an axis through this. And if I rotate it by 180 degree, then I will get the same molecule. Okay, so you can see that in this case, I'm having a C2V symmetry, whereas in this case, I'm having a D3H symmetry. And ultimately, you can see the optical racemization or isomerization has taken place. Okay, so if you look at the next slide, this explains it really well. Both are optically active. So that is why it is sometimes called as racemization also, because one isomer is getting converted to other and both the isomers are optically active. So definitely some racemization is going to take place. Okay, so I'll just summarize it so that it will be easier for you to grasp the concept. The first point is, let me just use some other marker. In summary, I'll just write down. So both these mechanisms, first point is that both these mechanisms are basically proposed for racemization or isomerization of octahedral complexes, particularly the tris chelate complexes, right? So that is basically why these mechanisms have been proposed, or what they are trying to basically portray, that how the racemization takes place, right? So in Bailar twist, we have a D3H transition state. It undergoes through a D3H transition state, whereas so I'll write B over here. And the Ray-Dutt twist, that I'll write RD, goes through a C2V transition state. Okay, so that is the key difference between both of them. Then the third point is that both of them have a trigonal prismatic intermediate. Okay, both of them have a trigonal prismatic intermediate. And in both the cases, these are twisting mechanisms. So there's no breakage of bond. Okay, only the bonds twist. There's no breakage of bond. There is no breakage of bond. So these were some of the important points that you need to remember when we talk about Bailar twist and Ray-Dutt twist. I am not sure what else they can ask you from this, but whatever to my perception I thought were important points, I have presented it in front of you. So those of you who did not have the time to go through these mechanisms, it is a quick summary of your Bailar twist and your Ray-Dutt twist, right? So anyway, I hope you found this video helpful. If you did, please do not forget to give it a big thumbs up, and do not forget to subscribe to the channel if you haven't already done that. I would really appreciate it. It really does motivate me. You won't realize it, but it does. Okay, so thank you so much for giving me your time, and I hope a question comes up from this topic and you are able to answer and get some marks for yourself. So anyway, all the very best for the examination. I will keep coming up with the videos regularly for the upcoming GATE examination, right? So thank you, and I will see you in the next video. Hey guys, so I'm a verified educator on Unacademy, and along with that I'm also available on the Unacademy Plus platform, where I'm taking live classes along with other educators. So in case you're interested in attending the live classes, you can subscribe to the Unacademy Plus platform using my referral code, that is SETHI, and that will give you 10% discount. Alright, and in case you're not interested in attending the live classes, you can watch the free courses that are available on the Unacademy. For that, all you need to do is go to the Unacademy website or download the Unacademy Learning app and search my name over there, that is SETHI. Once you do that, you will get the access to all the free courses that are available on the Unacademy platform.